Okay, dear students, welcome in science experiment session. Today I am taking one experiment which is based on the Archimedes principle. So let us have a fun with Archimedes principle. First of all, what is the Archimedes principle? So whenever you take any liquid, suppose I am putting the liquid in the glass, and when you immersed any object inside the liquid, then the when the body is partially or the fully immersed in a fluid, then it experiences a upward force on the body. It experiences the upward force on the body, and this upward force is equal to the weight of the fluid displaced. So this is the Archimedes principle. So what happens if the upward force, this resultant upward force, that is known as the buoyancy force. Okay, so this upward force, and we are taking the weight of the body. Two things: upward force, it is in the upward direction; weight of the body, it is in the downward direction. So if the downward force means weight is become greater than upward force, then the body will sink. Okay, if the upward force is become greater than downward force means mg or the weight, then the object will float on the surface. And if upward force and downward force means buoyancy force and the weight, they are become equal inside the liquid, then resultant force is zero. In that case, this body is in equilibrium condition. We can take the example of the submarine. Okay, now in this experiment, let us take what happened. I am taking the two glasses. In one glass, simple water is filled up. In the other glass, I am taking the simple soda water. Now this is the simple soda water. Now let us see, when I am putting the naphthalene ball, this is the naphthalene ball, inside this water and the soda water. What happens? When I am putting the naphthalene ball inside the simple water, it sinks because here the weight is greater than buoyancy force. Okay, now I am putting this naphthalene ball inside this soda water. Okay, now you can see it is also sink, but after some time what happened, you can see this is coming upward, it is floating. So actually what happened here, when I am putting the naphthalene ball inside this, you can see now it is dancing. Okay, this naphthalene ball is dancing inside this soda water. So here when I am putting this naphthalene ball inside the soda water, why it is dancing? Can you have any conclusion about it? Any reason? So the reason is Archimedes principle and the buoyancy force. Okay, when I am putting this naphthalene ball inside the soda water is filled up with the carbon dioxide. You can see the bubbles, that is the carbon dioxide bubble. Okay, this naphthalene ball is dancing. You can see it is going upward, going downward, again it going upward and going downward. Okay, and this process is repeating here. This process is going to repeat it. So what happens when naphthalene ball is put inside the liquid, then first of all here it sinks because the buoyancy force, upward force, is less than weight. or weight is greater than buoyancy force, so it is first sink. But after then what happened, on this naphthalene ball the bubbles of the carbon dioxide formed, deposited, so the volume of the naphthalene ball increased, so buoyancy force is increased than the weight and it is coming upward. But in the surface of the soda water, again these bubbles are break down, okay, and they explode into the air. And what happens, as the volume decrease of the naphthalene ball, it again sink, because here the weight is greater than buoyancy force. So after then what happened, again the bubbles are formed on the naphthalene ball and volume increase, hence the buoyancy force, upward force, is become greater than the weight. So buoyancy force, one type of the upward force, so it upward this naphthalene ball. So in this way this naphthalene ball is dancing, okay. So this is the experiment based on the Archimedes principle. So again, Archimedes principle is what, when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Okay, thank you.